Hello everyone, welcome to Nowhere. My name is Rizwan Ahmed. I will be your tutor for the project 6 of the Trainity project from the Trainity. So, and this is the sheet that we get from the Trainity. And what we have to do, we have to actually this is the sheet that we will be working with. So what we have to do, we have to calculate the number of blanks for every column. So how we are going to do that? We are going to insert three rows actually, three rows actually here. So one is blanks, then a second proportion, and third one we'll call it median and mode. So how are we going to calculate the number of blanks in each and every row in each column? By simply applying this formula, which is okay. I will be writing it here. By simply using count 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 blank function, this one, and then we'll select this array from B to all the way down. After we have calculated the number of blanks for the first column, we will drag this in the forward direction to automatically calculate for the blanks for the rest of the columns. Similarly, we are going to calculate the proportion. How are we going to calculate the proportions? Is by calculating the number of blanks, that is this cell B3. I think it is B4. Yes, B3 to total number of cells. So the number of blanks present in the column and total number of cells present in the column. So that's how we will get the proportion. And median is we have to simply apply the formula. This formula is equal to median. So that's what will return the value of every, and then we'll have to drag it forward for the automatic calculation. So also the median will work only for the numerical columns. So in the columns in which numbers are present, the median formula will work only for those. So, and for the columns having characteristic data, for example here, or in this cash loans, revolving loans. So we're going to calculate there is the mode of the column. So uh, the entry which has the highest number of counts, or the so that will be the mode of the column. So for example, I will show it here. In this column, unaccompanied, name type suite, unaccompanied, family, and there are a lot of entries. So in this column, unaccompanied is the mode of this column. So for the numerical columns, we'll calculate the median, and for the characteristic type, we'll calculate the mode of the column. So going forward, another step what we are going to do for the data cleaning is we're going to remove all the data, all the columns having the proportion greater than 50% or greater than 40%. It is up to us. So what I did here is I removed the columns. I deleted the columns which had blanks greater than 40% of greater than 40%. So only we have to calculate the median only for those having blanks in them. And then what we have to do is, for example, here the number of blanks present in this amount annuity column is 1. And then what we have to do, we have to replace this. We have to find this empty cell and then replace in it this median value. So how we are going to do it? We are going to do it by selecting find and replace. Replace here. We don't have to type anything, and then replace it with this number. and then replace it with the median. So and we'll do this for each and every column. So moving forward, so this is how we will clean the data. So for each and every column, these are the data cleaning steps. Okay, as you can see, none of the columns have the proportion greater than 40%. You know, there is a proportion of 0.002, which is like almost negligible, and an empty cell of 1. So this is not going to do this is not going to affect us in any way or form. So what we are going to do, we are going to replace the one cell, this one cell with the median number, and also here it is the number of blanks is 168, and the proportion is 0.33%, and you know, we have to we will and the median here is also 0. So here also 0, and we will replace it with the same. So we don't have to do it for every column. We have to do we'll do it for the column that we are going to use. So moving forward, what the first task is, okay, here like here, how we are going to this is how we are going to calculate everything. So how we are going to calculate the mode of the column. So we can use the column, we can actually if there is a characteristic type column, we can simply pivot the column, and we'll get the count of the each and every entry, count of each and every unique entry. So for example, unaccompanied here is greater, so that's how I calculated the mode. For the occupation type column, the number of laborers is comes at the most, which is 8,952, which becomes the mode for this column. So moving on forward, what we will do next is we'll also calculate the proportion of each column. We'll calculate the proportion of blanks in each column. So before removing the so here is what I would suggest. So before removing the columns, you know, having percentage of blanks greater than 50% or 40%, first of all we'll draw this graph, then we will delete them. Okay, so remember this, guys. We'll draw a bar chart or we'll draw a column chart after we have drawn this, and then we'll delete the columns having proportion blank proportion greater than 60 or 50 or 40%. Okay, so we'll do this with number of blanks to number of number of blanks with the name of column. So I think the second task is about calculation of the outliers. So what we have to do, we don't have to calculate it for every column. We have to do it for 2-3 columns or 4 columns at maximum. So here I have calculated it for like, I don't know, 3 columns I have calculated. So I have calculated for outlier for amount annuity. I have calculated outlier for amount to income total, and then for outlier for amount credit. So how we are going to calculate the quartile? So first of all, what we have to do is we have to understand the okay. So we have to use the box and whisker type here. So the middle one in this to understand this chart, what we have to do, we have to understand this figure first. So the middle value, it represents the median value. So above this, above the median value represents the 55% of the it represents the 75% of the median total value, sorry, from here to median to the median to the, I think this one is called third. This is the first quartile, this is the middle quartile, and this is the third quartile. So from the second to third quartile, it becomes 75%. So if here it is 50, then it will become 75, and if here it is 1, then it will become, so from here to here it is like 25%. So 25%, 25%, and 25%, it becomes 75%. So above the median value, it becomes they come in the outlier interval. So these are the first of all we have to calculate the minimum, maximum, and first quartile, middle quartile, and third quartile. So how are we going to do that? We'll simply use the formula is equal to quartile, like this. So after selecting quartile, so what we'll get is here. Okay, so in this, let me select this. Okay, after selecting the quartile, in a this formula will show us which type of quartile we are interested in. We are interested to find. So first quartile. So here you can see the 25th percentile. It is the 25th percent. First quartile is the 25th percentile of the value. So of the minimum value, and then second 50th percent and 75th percentile of the it represents third quartile represents the 75th percentile. So from median value to first quartile, there is a difference of 25%, and from median to third quartile, there is a difference of 25%. So above these, so and this median value represents the median. So above the median, so above 25% is above median value 25% is third quartile. Below median 25% is first quartile, and above or below the first and third quartile becomes the outlier. So above or below the third or first quartile becomes the outlier. So that's how we'll calculate these three graphs. Okay, I think we'll go for the next task. Yeah, I think yeah, we have to find out the data imbalance in our sheets. So again, we'll take 3, 4, 5 columns in which there is a data imbalance. So we'll take for example, we'll take the column target here, right? So if we look at the column target, it has values, for example, 1, 0, 1, 0, and in the column target, if you look at the if you have reviewed the data sheet and other documents attached to it, then you know that target 1 represents the people with difficulty in payment or defaulters, and 0 represents the non defaulters or the people having no difficulty. So what is the percentage of people having difficulty, and what is the percentage of people having no difficulty? So we can represent it by using a bar chart. So 92% of the people have no difficulty in repaying the loans, and 8% have difficulty in repaying the loans. So this is what the whole situation is about. So, and also we have to calculate the data imbalance ratio. Okay, I think here there may be a little bit. Data imbalance is actually from low number minimum to maximum. Minimum divided by maximum. So 4026 45973 divided by 45973. So here I will change it later. So remember guys, data imbalance ratio is minimum to maximum. Minimum divided by maximum. So similarly, we have name, contract type. I think I have made a mistake. I have put it here as maximum divided by minimum. So I think I will correct it later on. Here I have made the same mistake. So here in this name, contract type, there are two categories: cash loans and revolving loans, and we can see their proportion here. Similarly, we can do this for the code gender, female, male, female, and count children. okay, how many of the people have one children, how many of the people have zero children, two children, three, four, five, and we can see it here. Okay, and here is the chart explaining this situation. Okay, I think we are done here. And another univariate analysis. Okay, what univariate analysis represents? It represents the okay, what univariate analysis represents? It represents the how we are going to it basically it say it represents the analysis of a single column. So I will show you the example here. So this I have made a bin here for this column, amount, income versus frequency. So I have used the if you don't know the formula, you can use the frequency. The formula is this, FR. So this is the formula, but first of all, how we are going to use this formula? We have to make a bin. How bin data, how we are going to do that? So we have to make sure this the category, the range of the total income column falls into that bin. For example, what I have done here. So this is the bin that I have made. Yeah, I have made a from 50,000 to 2,50,000. So I have made a bin and greater than 2,50,000. So I have made a bin here. So what I will do here is I will calculate the frequency, and after calculating the frequency, what it will do is it will calculate the number of seller incomes falling in this range. Less than 50,000. Okay, here I should have put less than 50,000. If you are not going to do this, if you are if you say that, well, I cannot, there should be some another trick or formula to calculate to make these groups more attractive. For example, simply writing, I will show it here, less than 50,000, 10,000. What you can do is I will show it here one time. 50,000, 50,000 to 1 lakh. Now what we are going to do here is, okay, we can make another, or we can leave it. We can use the formula concatenate. We can use the formula concatenate and then use function right, and then you select this column, comma, and how many are there? 1, 2, 3, 4, 5, 6. So 6, select and comma, and again we are going to choose the right. Okay, so we will use the plus function here. No, this function we will use. Okay, this is how we are going to use this, comma, and then we'll use the right function again, and we'll select the same, comma, 6. But after that, if we are going to make the group of like 50,000, 50,000, a lakh, 1,50,000, and the difference is common difference between the same groups or the same range is 50,000. So we'll do the plus 50,000. So that's how it will. Okay, I think I made a mistake. Yes. So what we are going to do, we are going to simply drag it here. Alright, so here is your group. And after completing it, how are we going to do this? How are we going to fill the total amount total income into this group? So in a simple formula, by using a simple formula. Well, it's not simple, but it is fun to learn all the new things. well, at least it was for me. So this is how we are going to count, how we are going to put all the amount income in this. I'm gonna show you a demo. So what we'll do is we'll use this formula count ifs, actually count ifs, and then we'll use the left function. No, first we'll choose the range. So what we'll have to fill from. So this is the range I choose. Okay, I'll choose a little bit of, I'm not gonna go that far. So comma, I'm gonna just show you the formula how it is done. So and then another, this is the range we have to choose from, and you can select the whole column. So this is left function, and we will choose this comma 5. Okay, here I have to again we'll choose a range. We'll choose less than, and write this comma 6. Okay, I think it should have worked. I don't know what happened. 1 second. I don't know why it is not working, but wait a second. Okay, now I think I had forgot to close the end bracket, so that's why it wasn't working. So the number of ranges in the 5,000 to 10,000, 50,000 to lakh is 2, and then we can use the same thing here. Okay, so you can use it. And for the 50,000, what we can do, we can change the formula a little bit. We don't need this one for this, so we have to change a little bit here. Actually, also this we don't need. Yeah, here. So 6 fall in less than 50,000. So moving on forward, we have wasted a lot of time. So I have showed you how to make the groups, so you can do it exactly like this. So we can for the amount credit, we can also do the univariate analysis. So this is exactly how we'll do it. We'll calculate the, and also the results we have to highlight. What are the results that we got from it? So in this column, amount income total, after calculating the number of groups, and putting the income in the bin, putting it in the bin by using the frequency formula. So we can see that the majority of the applicants have an income range of 100k to 200k. So that's how we can that's the analysis we get from a single column. That's why it is a univariate analysis. If it was from the two columns, which will see moving forward, uh, then it would have been called the bivariate analysis. And similarly, we can say that for multiple columns, multiple column analysis, we can say that it is a multivariate analysis. So moving on forward, similarly in this credit amount, I think we can do the same. We can make the groups using the bins, or by making the group and using frequency formula. We can calculate the same analysis. We can get the analysis like this. Loan tendency increases from 50k to 40k 400k. As credit score increases, the loan tendency decreases. Okay, this is the analysis that we get from it. And also for the age category, we can do this here. Age group 30 to 39 is the most category applying for loans. Similarly for different, we can do the same. Okay, finally for bivariate analysis, we can do here. Okay, let me show you what bivariate analysis is. As I have told you earlier, bivariate analysis involves two types of data sets. So we do the analysis for two types of data sets. So this is what I was talking about. So we select the income range, and we'll select the total, and also we'll use this target total income. Two types of columns we need is total amount, total income, total, and target column. I have already told you what it is. It one shows the number of defaulters and 0 shows the non-defaulters. So what we're going to do is we will see income range. All right, so income range is going to be this. So we, in the similarly way I have shown you in earlier example, we're going to create this group, and then we'll calculate the total number of applicants. This is the formula how we are going to calculate it. So this is for the total applicants. I have shown you how we are going to calculate this total applicants. Okay, from 0 to 500, 50,000, 804, and this. Similarly, in the same way, we are going to calculate this. This is the formula here. I'm gonna highlight it for this for you. So this is how we are going to do this. We'll just drag it here, and we'll make certain changes. And this is the formula that we will be used to calculate the defaulters. All right. So use this formula to calculate, use exactly the same kind of table. After getting the insights and the data, we can make the graph. So I will share the graph with you right now. Where was it? I think I may have deleted it. Don't worry, I will recreate it then. So we can make the graph by simply using non-defaulters and defaulters. So this. Okay, where is it? I will insert a graph here. Okay. Or I can do another thing. I can insert a bar chart. But let's just forget it. This is the insight that we get from here. So we can cancel from here to here, as from here to here it is very less data is going, getting very dim. So we can cut it up to from 5,000 or 4 lakh to 400, 450 lakh. Okay, what I'm going to do here is I can simply do this. Yeah. Okay, yeah, now it is good. So this is how, from the analysis, so we can see that as the as the income increases, the number of defaulters also go on decreasing. So this is the chart for this and the insiders. So we use we can see the income also, and we can see the with respect to the income group, we can see the number of defaulters also. We can see that as the income increases, the number of defaulters go on decreasing. Going on to this another one. Okay, I think I have made two times the same analysis here. So I have already explained it. I have already explained this to you. Okay, so for the credit range, we are going to do the same analysis, in the same way. I have used a bar chart here. So we'll also, what we are going to do is we are going to work here with amount credit and target column. So in the same way we are going to make the credit range group, 0 to 50,000, 50,000 to lakh, and then calculate then the respective count of loan range credited, and count the number respective ranges. So 90 has been 90 people have 90 people have been credited this amount from the range 0 to 50,000, and 89 out of the 90, 89 were defaulters, and 89 were non-defaulters, and one was a defaulter. So we can see that clearly here, and we can draw the graph. So we can include this also, but it's not that important. We have to make non-defaulters and defaulters make this also. So this is it, and similarly for the age group. Similarly, this is the age in days, as you can see in the application data sheet. So there will be age in days, but you can convert it into the age by dividing it by 360. So this is the formula I used, and I the points around AW2 by 365 minus 365 and comma 0. So this is the formula that I used to convert it into the number of years. So what round will do, it will convert it into the roundabout. So if it is close to 26, then it will do exactly, it will give us the exact number 26. So we don't want we don't want age in like 26.5, 26, but we want the exact number. So that's how I did it. So similarly, we can do the now we can create a age group 25 and with difference of 5 years, and we can calculate the non-defaulters, defaulters, and similarly draw the group. So, and also similarly for the name, family status, target, and for the category and for the married family status, we can do also this kind of analysis. So I think another sheet where I had to show the correlation. So I think it's not here. Open. Yes, here it is. So this is the correlation sheet that we're going to do. We're going to find correlation for non-defaulters. Actually, what we'll do, we will take these columns here. The name of these columns, count children, in the horizontal vertical direction, in rows and then in columns. So what we'll do is we'll calculate the relation for each and every column. So we'll calculate the relation of count children with count children in the amount income, amount credit. So and for the for each and every column we'll calculate the relationship. So how are we going to calculate the relationship? By using this formula. All right. So you get this is the formula. Note down this formula and then use the you can log it and then use the drag function. You can get these results by using the drag function. Similarly, we can calculate the correlation for defaulters. So first of all, what we have to do, you have to filter. You have to use the filter function and calculate all the results. This is the sheet for. Okay, I'll show it to you. Yeah. So for calculating this correlation, what we are going to do is we're going to first of all we'll copy and paste them in a new sheet. Copy and paste all the columns mentioned here, which are these. We'll copy and paste them in a new sheet. So these are like 8-9 columns. So and then we'll filter them for. We'll take all the columns and paste them here, and then using the filter function, we'll filter all the values for 0. So this is the filter function that we are going to use. We are going to use this in all for all these box, but only for 0. So this is a here a5 double a5 50,000 is equal to a3. My a3 here is 0. 0, as I have already mentioned, is for non-defaulters. 0 represents the non-defaulters. So this filter here, these values here are the values for of all the these are the values of all the columns for 0. Similarly, for this one, these represent the value. These represent the value for 1. So as I have already shown here, this is the filter function for this. So these are the values of the respective columns for the value 1, which represents the defaulters. So for using correlation, we can use a separate sheet. So for calculating relation between count of children and count of children, we simply use correl. And we can use the formula. We can give the respective references for each and every cell. So in this row, okay. I think I made a mistake somewhere. Okay, these are the values. So this is how we're going to calculate the correlation. So the correlation between count of children to count of children comes out to be is 1. And then what we're going to do, we're going to drag it, and we'll get this results. So remember to log the values of these of your sheets, but as we proceed in the row wise, that is in the downward direction, make sure to change the values of the column. So for example here, what while moving on to this, what we have to change is something has changed a little bit of so this reference will remain the same because it is for the count of children. So this reference will remain same, but in the sheet 2, you see uh, there is change in this area. So you see here, so it changes from M to N, you can see. Okay, and then we have to log the values N, and then we drag it in the forward direction, we'll get the automatic results. And similarly it changes from N to O, here it changes from Q, and then similarly we can see it. And similarly we can do this for the correlation for defaulters. Also, one thing I forgot to mention is we have to also do the same analysis for the one more sheet that that the Trainity provides us. I think if I have it, I'll show it to you. One second, I think I have it. No. So we have to do the similar analysis for do this a little bit of analysis, univariate analysis and bivariate analysis. I think I have erased the data, so do a little bit of same thing we have to in the previous I think the name of the application is data sheet is previous application. What you have to do, you have to do a little bit of univariate analysis for the same columns, or you can do it for the different columns, and a little bit of bivariate analysis from from this column, from the previous data column. So incorporate those sheets, those charts into your doc, PDF or PPT also. So that's it for the project 6. Thank you guys. Please do like, share and subscribe this channel. I'm also new to the channel, so please do support me, and also you can brainstorm your ideas in the comment section and give all types of suggestions. Thank you.